Thanks for having me in this very interesting conference, and thanks to the organizers for organizing this for us. The subject today is user interface, and that's a subject that many of us have experience in building software. My background is I'm the founder of a company called Ulysses Systems, and we build software for the marine domain. So we have hands-on experience, as do you. So I think it could be wrong if I was to suggest A to Z ways to build software when I don't have any more expertise than any of you practicing user interface design and implementation. So what I'll stick to is the user interface, I would say, core issues that might not be emphasized as much. Not that they're not emphasized at all, but they're not as emphasized as we'd like to make them. So in this discussion, I'll mention a few points that are perhaps part of other points that are well known, but not as emphasized as we'd like them to be. Relevance. Relevance is a key factor in user interface, and it's not a surprise to anybody. You have to provide screens of relevance for the user to get to where he wants to go, and then to carry out the interaction that the user wants. So relevance is pervasive. We all know it's an issue. What may not be common knowledge is what are the building blocks of relevance, but we'll get to that. The most important factor in relevance and in user interface design is understanding the domain. That means understanding the user's world. It's not just understanding the transaction at hand, it's understanding what else is going on and what the user may do after this and what variations of the process may exist, and all the factors that are not obvious to somebody that's not in the domain. For example, everybody says that in user interface design that rollback's a good thing. You need to be able to go back in case the user makes an error in navigation. Going back is not a user interface problem, it's a logic and domain expert's problem. Domain expert has to know when you're rolling back what will happen to the system with your rollback. For example, has there been a concurrent transaction that makes your contribution important, and so rolling it back means that the other transaction has to be rolled back. Or is it clear to the user that the transaction he's about to perform is according to expectations, that it's not short of what he expects or doesn't ask further questions than what he expects or has answers for. So understanding the user's world, understanding the domain, is a primary issue in user interface design. We'll go into some more details on that soon. The second component of user interface design, in our opinion, is the issue of building blocks for user interfaces. And by this we don't mean building blocks, rendering building blocks, in other words, things that you might think are useful in providing components of your screen view. This is an issue, but it's not an issue that hasn't been addressed. The fact that you need to use a lot or repeatedly takes care of the fact that they are usually components. The components we're talking about here are components of abstraction. In other words, that depending on what application you're building, there are abstractions. If you're building a decision-making applications, then the relevant abstraction could be background knowledge, could be similar processes to the one at hand, contributing processes to the one at hand, outcomes of the process that is about to take place, expected sequence of user interactions, alternative sequences of user interactions for a process variation, importance of one step of a process over another. All these things are abstractions of decision-making, let's say, system. If we were to design a emergency response system, the abstractions would be related very closely, but not the same. There would be outcome would be important, contributing processes to the goal. The emergency response goal would be important. Causal processes that could be impeding the success of the emergency response, and many other abstractions that are actually relevant to that kind of application and not another. A graphical application would, of course, have different abstractions in itself. So the point I'm making here is that you need to make those abstractions, and those are going to be components of perhaps thousands of interfaces. Thousands because large applications have more than a few interfaces. If they only have a few interfaces, that's not a good thing, because it means they're not tailored to the task at hand. So managing many interfaces requires managing common abstractions, and that is those are building blocks for building your user interfaces, and perhaps more than that. Just to point to the concept of abstraction, these are cognitive abstractions. They're not abstractions of some rendering. So, for example, many instructions and user interface instructions tell you that you mustn't have a list of more than 5 choices. That begs the question on why aren't people confused by phone books and guest lists and product lists and so on. There's a lot of lists around that people don't confuse people, and there are more than 5 choices. The answer to that is because it's not about short-term memory, and people don't have good short-term memory, so they don't remember the 5 choices. It's that or more than 5 choices. The issue at hand is that the user looks at the screen and connects what he sees on the screen or she sees on the screen with an abstraction in the user's experience. If one sees a phone book, one knows there'll be names in the phone book and phone numbers. If one sees a guest list, they will expect to have names. So the expectation of the user is based on an abstraction of what he's about to look at that relates to the user's experience. It's really got nothing to do with memorizing anything. The part that's memorized is the part that's already there, that a guest list looks like this, a phone book looks like that, a product list looks like this, list of machinery looks like that, list of spares from a machine looks like this, and so on. So really the concept that needs to be kept in mind is you need components to build user interfaces, and you need abstractions in order to solicit the user's understanding. More reasons why you need a componentized user interface come from the fact that you may have many user interfaces that you need to build, and because you have a large suite of applications that cover a broad aspect of the enterprise, and those aspects of the enterprise are related, and so there is a relationship between them, and therefore the same users may be using different features from different applications, and so there is a need for consistency, and there is a need for the ability to recognize quickly where to find things that are relevant to that particular feature. That relevance to the particular feature is a major part of a smooth user experience. If the feature doesn't look familiar, then the user won't recognize it, may navigate somewhere else. So you need consistency in order to build things. Also, you need to build things consistently and efficiently. Building blocks are the core of manufacturing, and they also have abstractions that are relevant to the type of thing you're manufacturing. When you manufacture a ship, you build it in units. This is because the units provide commonality between the components in the units, and the way that the units are built and enable the ship to be built quicker with a distributed workforce and therefore much more efficiently. That brings us down to the concept of user interface components in the actual design and building of software. Perhaps when we design software, we have lots of documentation to explain what everything does and why it's the way that it is, although I doubt that the documentation keeps up with the development of the software. But when we maintain the software, we're usually adding features to the user interfaces, or we often add features to the user interfaces. Adding features to the user interface is not going to be very efficient if there's no building blocks, and you have to start with a user interface just with rendering blocks, because the building blocks help you build and help you create, in fact, create the means for the user to improve the user interface as well. So important to having many user interfaces, and also important to developing and maintaining and improving software, is to have components of user interface. This brings us to handheld devices, which are a much more intense use of user interface concepts. This is because the handheld device is very small, and in being so doesn't have the space to show you what's going on and where you are, where you'd like to be. So even if you have building blocks, those building blocks may not be on the same page, so on the same screen, so you may need to know how to get to the other screens. And so again, a selection and a consistent selection is extremely important. You don't want the user to get used to the abstractions of your components, and then find that this abstraction is not consistent across all the user interfaces that the user is coming across. So it's extremely important to stick to the relevance issues that we mentioned, the domain expertise, understanding the use cases, and having consistency in the use of components, abstracted components, with handheld devices. An additional concern with handheld devices is the issue of relevance with respect to what's going on in the business and what's going on in the enterprise. We often hear that a good user interface tells you what status your application is in, but the status of the application is more than just showing you what your stage of your transaction is. It may be the stage of somebody else's transactions. As mentioned earlier, if there's a rollback and this involves somebody else also having to roll back, the system must know what's going on in the enterprise with respect to your transaction at the time. There's also a concern with handheld devices that if you only have one for every application that you're using in your enterprise, then you may be taking up space and time with the transaction you're doing, time better spent on something else that's more urgent in your business, like a contract not coming through and having to reschedule lots of procurement tasks, for example. So the concept of situational awareness is even more important with handheld devices, because handheld devices are more difficult to navigate in order to find out what's going on. So the concept of situational awareness is a big one in software. It means that there must be an easy way to figure out what the software is doing at the time, which currently is not the case. Most software designs don't make it clear what is the situation of a larger system with interrelated processes. Finally, I'd like to say that the most important guide to user interface design is one's own mind. One's own mind has the fastest, most efficient retrieval of information relevant to a task or goal, and the interface between memory and reasoning is extremely sophisticated in the human mind. And it is this template that we should be looking at for building user interfaces. Perhaps physical ones have physical user interfaces, like maps have different relevance criteria, but the human mind is the key to understanding user interface and producing good user interfaces. Thank you very much.